Right. Once again, this discussion is being recorded, so you'll actually surely get the recording after this so that you watch and do the exercises I'm going to
Okay.
give to you from the set of problems that are here. Right. Targeted worksheets, mathematics, grade 7. Right. So we shall be looking at a specific part of the grade 7 syllabus. Okay. To start with, we shall be looking basically at the topic on integers. There are certain numbers that are of interest to the grade 7 learners on integers. So we begin by looking at the basics and we build from bottom up. Right. As part of what the grade 7 learners need to know is actually how to deal with number patterns, how to extend number patterns, and how to fill in the blanks. For example, if you look at question 1, is what is going to come in the exam, and so and we're looking at more things that are going to come in the exam, in the grade 7 exam. But obviously, these are nationally benchmarked. Like question 1, we are looking at 1.1.1. And what is
Okay.
1.1.1 about? It is certainly about patterns, okay? So um, fill in the missing values of the following number patterns, right? So how do we fill in the missing values? So let us learn these together, okay? Let us learn these together and make sure that we understand this very well. How do we fill in the blanks here? Right. Fill in the
Yeah.
missing values. What are the missing values? What is the first number? It is minus 28. Okay. Right.
Mm.
So so you're gonna be watching. If need to be, from time to time, I'm gonna ask you to contribute here and there. But by and large, you'll just be watching the discussion.
Okay.
Minus 28, blank space, minus 20, minus 16, blank space. So we're asking the question, what number must be here? Because now we're starting from minus 28, then there's a blank, a minus 20, then minus 16, then another blank space. We can see that, for instance, from minus 20 to minus 16, 20 and 16 differ by the number 4. Okay, magnitude 4, size 4. Without the direction, without the sign.
Yeah.
Okay, right. So it means here, if you have minus 28, there is a number that differs from 28 by 4 because we have 20, then the number is it's actually 4 less. Okay, if you say 20 minus 4, you get 16, and all the
Yeah.
numbers are negative here. So here it means you must subtract 4 from 28. All the numbers are negative. So if you subtract 4 from 28, you get what? You get
24.
24, right?
20.
But it must be negative. You agree?
Yes.
Right.
Yeah.
Next. These ones are there already. If you look at the number minus 16, you must subtract 4 from it and maintain the sign. So if you subtract 4, 16 minus 4 is what?
Well,
Actually
negative.
12, right? And you put
Yeah.
the negative in front. Right, we are practicing together, and there are a lot more that are going to appear, problems like that. The
Okay.
next one has the number 24, and then the number 12, and then the number 0.
Well,
Right,
okay.
clearly now we need to just, what are we doing here? We need to fill in the missing values. Right, so if you have the number 24, and then you get to 12, after 12 you get to 0, what has happened? What has happened? Because it actually means that the number 24 was reduced to 12. 12 was reduced to 0. So it means that somebody was subtracting 12 here because it is 24 minus 12, that gives 12. And then if you have 12 and you subtract 12, you get 0.
0.
If you have
Yeah.
0 and you subtract 12,
Get negative 12.
we get negative 12. Good.
Yes.
You get negative 12.
12.
Next, if you have negative 12 and you subtract 12 from it, what do we get?
We get negative 24.
We get negative 24. Well done. I'm happy that you are following this discussion. Beautiful contribution there. Next, you have minus 36. After minus 36, we get a minus 25. So we can see that if we ignore the negatives, the number 36 has reduced by how much, for instance? So it has reduced by 11. Okay.
Okay.
Because if you say 36 and you subtract 11 from it, you get 25. All the numbers are negative, so we are fine with that. Next, we have the number 25. It has got to 16. It has reduced by how much? This one here.
16 is negative 5.
Yes, okay. Yeah, that's fine. All right. So we're thinking about these together because it is a practice exercise in preparation for assessments. Okay, in preparation for assessments there. Okay, right. So now let's do this here. So we can see that once again from 36 to from minus 36 to minus 25, then from minus 25 to minus 16, right? And then now what has happened? So in other words, we do these here. Right, you can do these small maps here. Right, so if you have now 25 and 36, the difference between them is what? Is actually just 11, right? And then now
Yes.
you realize that the difference between these two guys here is what again? Right, so it is actually, if you say 25 minus 16, what do we get? 25 minus 16, what do we get? We get a
negative
9. Right, we get exactly, yes. Yeah, 25 minus 16. I'm ignoring the signs for now, okay? So if you say 25 and you subtract 16, you get what?
negative
Okay, but
6.
yeah, we ignore the signs. Okay, that's fine.
Yeah.
That's okay. That's all right. Now we continue with our discussion. Right, so the question then is, what is then the next digit that must follow after that? All right, so because you saw the magnitude was, right, if you say this minus that, so the magnitude was 11. Here
11.
the magnitude was 9. And then here, so now how was this then changing? Okay, because it was 11, then it became 9, and then what will the next one be, for example? Right, so, okay, I want you to look at this and think very, very carefully and see what we are thinking about this, because this is a very interesting question. So you can see that the difference is not the same. The difference is not what? It's not
Not the same.
the same.
Not
Because
the
it's
same.
11, then 9. So it means to us that the examiner must have thought about powers. So we think about two things in mathematics. Either we think about the powers. We're going to define powers. If we do not think about powers, then we think about what? We think about differences. We think about differences. So the differences are not working in this problem. So we're going to think about the powers. So in other words, now it means that this one is 6 squared. This one is 5 squared. This one is 4 squared. Because if you say 6 squared, what is 6 squared? It's 36. 5 squared Is 5 squared is the same as 5 by 5. 5 times 5 is 25,
525.
right? And 4 times 4 is 16. So the next one, because it's 6, then it reduces by 1 to 5. It reduces by 1 to 4. It reduces by 1 to 3. It reduces by 1 to 2. And so you can say it reduces by 1 to 1, okay, if we just would continue with the pattern there. So it means, therefore, if you say minus 3 squared, what is 3 squared? It's 9, so this will be minus 9.
Yeah.
Okay, so you need to think about these things. So that will be minus 9. Then after minus 9, you have 2 squared. What is 2 squared? Okay, all these are negative numbers. 2 squared is the same as 2 times 2. What is 2 times 2?
4.
4.
4.
Okay, thank you. So we have that. So you don't need to worry much about having to copy these things down. So yeah, just to note exactly what's happening. So yeah, not worry much about copying yet. And because this video is going to be available for you to basically watch and make sense of these things. The next question. Okay, in grade 7 now in the exam, they're going to ask you something like this. Write the correct sign between the numbers. Okay, so they want you to write either greater than, less than, or equal to. Okay, so we have 1.2.1. Here's the question. You have minus 9. And then we must put a sign here, either the greater than sign, or you must put the less than sign, or you must put the equal to sign. Okay, so if we compare minus 9 and minus 9 over 1, which one is bigger? Which one is greater than? Which one is less than? Which one is equal to? So what sign do we put? Do we put a greater than? Do we put a less than? Do we put equal to? Okay, but we realize that if you divide minus 9 by 1, you get minus 9. And minus 9 is equal to itself. Is equal to itself. And therefore, these two are equal to each other. Okay, so there is an equal sign there. Okay, next question.
Divided.
1.2.2, you have minus 30 together with what? With 30. And
30.
so what sign here? Is it greater than? Is it less than? Is it equal to? Your thought, please.
Less than.
Well done. Okay, congratulations there. Okay, it's less than because a negative number is less than a positive number, right? A negative number is less than a positive number, always. So no doubt. No doubt about that. Okay, so yeah, we continue. Let's look at 1.2.3. We have minus 101. What sign do we put there? It's clearly a less than sign, right?
Less than.
Okay, it's less than sign because we have a negative number, and a negative number is actually less than a positive number. Next question, 1.2.4. 1.2.4, you have minus 26 and 62. Okay, so we agree that at this point, what we are having is the following, right? What we're having is the following. So in 1.2.4, you have the less than sign because the negative number is less than the positive number. Okay, so we're good.
Yes.
Right, good. Right, we continue. So we are practicing this for the grade 7 exam. It's an exercise. These are exercises in particular. Arrange these numbers in ascending order. So we're learning what you call the ascending order. That is the concept. So if we are to organize them in ascending order, we start from the smallest of the numbers. We start with the least, the smallest one, the least one. Okay. So which one is the smallest? If you look at this 300, there's minus 320, there's 302, there's minus 300, there's minus 302, these 320. Which one is the smallest of all of them? That becomes the question.
Minus 320.
Yeah, well done. So we agree that minus 320 is the smallest of all the numbers. Correct. The next one after that is what? Would be
Minus
minus
302.
Yes, minus 302. Good. The next one, it's minus
Minus
300, right?
Yes.
What do you think? Is it minus 300? The next one.
Yes, it is minus 300.
Well done. Thank you. Minus 300. Okay. And then we have the next one after that. After minus 300, what is the next one?
300.
It's exactly the number 300. Well done. After 300, we have another one. What is the next one after 300?
302.
There is 302. Well done. So you have 302. After 302, what is the next number?
320.
320. Well done. Okay, so we have to do these and for just 3 marks, then we would get the full marks there. We have that. Now we need to arrange these numbers in descending order. Descending what? Order. Descending order. So now descending order means that they are descending in magnitude or in size. They are descending this. So we start from the biggest to the smallest. Okay. We start from the greatest to the least. So now we're going to see that the biggest one is what? Is the number 51. Right after 51, we can see that after that, the one that follows is the number 15. After 15, the one that follows is the number 0. After 0, the one that follows is the number minus 15. After minus 15, the number that follows is the number minus 50. Minus 51. Okay, yes. After minus 51, what follows? Okay, so
minus 115.
Minus 115. Okay, so we have organized and arranged these numbers in descending order. So descending order means that now we are beginning from the biggest one to the smallest one. Okay, we're good. And we're doing very, very well. Very, very well. Very, very well. Next question. Let's look at question 3. Subtract the integers without using a calculator. You may use a number line. So here now they're just reminding us that, okay, because we're in grade 7, we may use a number line because next year we want to go to grade 8, we want to go to high school, we want to finish school. You get the point? Okay, right.
Yeah.
So subtract the integers without using a calculator. Okay, if we have these integers, how do we subtract them in 3.1? Okay, we don't need to use a calculator, but you need to actually do the subtraction of these numbers. And now, okay, there are a couple of ways to do this. They said we may use a number line. What is negative times negative? Okay,
positive.
Negative times negative equals positive. And then what is positive times positive? It's positive.
Negative.
Okay, that's fine. Okay, I'm just giving you some of these basic rules so that because they are very handy here. They're very handy. And then we can use them. And then I'm going to give you some basic rules that you can use to remember these. Okay, now we can wish to multiply a negative times a positive. What is a negative times a positive?
A negative.
A negative. A positive times a negative is what? Is a negative. So what we are saying, we don't need to memorize anything here. We don't need to cram anything. But what is very important for us is to remember that if you are multiplying two different signs, the result is negative. The result is negative.
Negative. Okay.
But if the signs are the same, like negative and negative, we're multiplying them, it's positive. Or you're multiplying positive and positive, what you're getting is positive.
Positive.
So that is what happens, you see? That is what happens. So you need to subtract the integers without using a what? A calculator.
Okay.
Okay, let's come to this one. Now we have negative times negative. What is negative times negative? It's plus.
Positive. Yeah.
It's positive. And then we have the number 12 plus the number 14. What's the answer?
26.
26. Well done. Next, we have minus 10 minus 2. Minus 10 minus 2. Okay. You might have seen something like this before. Both numbers are negative.
Negative.
Okay, if the two numbers have the same sign, if they have the same sign, what do you do? Okay, what do you think the answer is to this one? Your thoughts? Because I always give people a chance. Yes.
Okay, and a negative minus a positive.
Okay, I know you can think that way. Okay, now this is the law. So there are two laws. Okay, there is rule 1, and then there is rule 2. What is rule 1? Right, so what is rule 1 here? And what do we do with rule 1? In rule 1, we say, if the signs are the same, if the signs are the same, take the common sign, and add the two numbers. If the signs are different, take
the
what do you think? So you take the sign of the bigger number.
Oh.
So you take the sign of the bigger number, and from the bigger number,
from the bigger number, and
from the bigger number you subtract. You subtract the smaller number. You subtract the smaller number. Okay, so we have this. So, what does it mean here? Now, here the signs are the same. So if the signs are the same, you take the common sign and you add the two numbers. So here the signs are the same. So you take the common sign, and the common sign is negative.
Negative, yeah.
And then you add the numbers. You add 10 plus 2. What is 10 plus 2?
12.
12. And that's the answer Okay, obviously I said without using a what?
Calculator.
Without using a calculator. So I know the calculator is going to give you minus 12, but we're saying let's not use it here. Okay, let's look at 3.3. What do you think the answer is to 3.3? Because it's 2 marks. I'm giving you like 2 minutes to think about it and you let me know when you're done. 3.3.
Okay.
Okay.
It is 20.
Well done. Because first, here we must we must multiply negative by negative. Negative times negative is what? Is positive.
Positive.
Then you have 13. What is 7 plus 13?
20.
20. Right, so nothing to do there. In 3.4, we have that the signs are what? In 3.4, the signs are the same.
The
So we
same.
said if the signs are the same because the 9 is negative, but also the 5 is negative. So we take the common sign and then we add the two numbers. 9 plus 5 is what?
14.
Is 14. 1, 4. Next. Right, if you have minus 12 in parentheses, minus 12 in brackets, and you subtract 5, so it's the same as minus 12 minus 5. Right, so the signs are the same. So you take the common sign and you add the two numbers. Right, you have 12 plus 5, which is what? Which is exactly 17.
17.
So the answer is 17. Okay, we are recording this discussion and therefore you will have a chance to write the notes at the end of this. So you need to scribble some notes about what we discussed today, the questions and the answers, so that you can have them in a separate book. You can just take your book from the lower grades, be it grade 11, grade 6, grade 5, etc. You take that book and you note the questions and the answers. Let's look at question 4. Use properties of integers to complete the statements. The 8 here, 8 plus minus 3 is equal to what? So if we say 8 plus minus 3, what can we put in the place of the blank here? So that when we add to 8, these two are equal to each other. Okay, we think about this. So it is these numbers, you're just switching them around. You're just what? Switching them around. So, yes. Okay, we call these, use the properties of integers. We call these commutativity. Commutativity. What is commutativity? We say the numbers commute. What is to commute? To commute, you can say, is to travel. For those who are traveling from place to place, they're said to be commuting. Right, so now if you have A plus B, it is the same as B plus A, and that is what we call commutativity in mathematics. They switch places, the numbers around the binary operation. Okay, because we have the binary operation, which is the operation between the two numbers. Okay, so in other words, if we have the number A and the number B, which are letters, of course we agree, and we let them switch their places that way, we call these the binary operation. So if you have 8 plus minus 3, what does it become? It becomes minus 3 plus 8.
Yes, yeah.
So, and then if you wish, you can put this one in parentheses like this. You can put that one in parentheses. That way, let's look at the next question from grade 7. Right, if you have minus 6 plus 2 plus 4 is equal to, okay, minus 6, minus 6. Now there is a 4 next to the minus 6 because we had a 2 next to the minus 6. But now there is a 4. And then there's nothing here. And we can see that the 2 was next to minus 6. Surely it is the number 2 that we must write here because there was 2 there. And then now suddenly the 2 is gone. next to the 6, next to the -6, the 4 has been brought in. And then now we can see the 2 is the only one that is missing on the right-hand side of the equation. And therefore we have 2 and we've put the 2 there. Okay. Right. Think about these things. State which property was used in question 4.1.1. What did you say the property was? Right. It is the commutativity. Commutativity. Right. We call it commutativity. Commutativity is just the numbers switching their positions around the binary operation. So in mathematics, we learn 4 binary operations. What are the 4 binary operations that we learn in mathematics? The 4 binary operations. Have you ever heard of them?
No, I have
No.
not.
All right. We'll look at the first one. The first binary operation is called the plus sign. Right. The next binary operation that we learn is actually multiplication. So this one is a binary operation. The plus is called addition. This one is called multiplication. Okay, it's called multiplication. And then we have the third binary operation that becomes the opposite of addition, and it is called subtraction. And the subtraction binary operation helps us to evaluate the difference between numbers. Then we have one more binary operation, which is called the inverse of multiplication. The inverse of multiplication. So the inverse of addition is subtraction. And we speak about the inverse of multiplication. And the inverse of multiplication is what? Is division. It is division. So these are the 4 basic binary operations we learn in the school curriculum. Okay, but there are more than these in mathematics. Sorry, there are infinitely many. How many are they in mathematics? They are endlessly many, but these are the basic ones, because sometimes we at university we have more of these. Okay, even in high school, if a student or a learner does technical mathematics, then they'll realize that there are a lot of binary operations also in the high school curriculum. Okay, we proceed now. In 4.1.2, state which property was used in 4.1.2. In 4.1.2, what happened? What actually transpired here? Because you had actually -6 plus 2. After that, okay, so in 4.2.1, you can write your answer in detail and say, we said it is commutativity, or you can say it is the commutative. The commutative property of addition. Of integers. Okay, now you have 4.2.2. What property was used here in 4.2.2?
Commutative property.
Okay, that's fine. That's fine. That's fine, because it's tricky. 4.2.2 is tricky. Right. So in 4.2.2, we're going to learn about the property. And the property in 4.2.2 is it pertains to what we call the use of parentheses. The use of parentheses. So if you have A plus B plus C, it is the same as A plus B plus C,
B
like this.
plus.
Right, so we have this. So that becomes the property. So this property now is called the associative property of the addition of integers. So in other words, this one is called associative. It's called the associative. Associative what? Property.
Property.
Yes, associative property. What is associative? What is the associative property? Okay, because this is the grade 7 curriculum. So you need to know these for exams. In case they even bring what you call the annual national assessments. Have you ever heard of the annual national assessments, the ANA? Have you ever heard of this?
Yeah. Yeah, I've heard of it.
Yes. So they might bring this, and now normally these annual national assessments come from the Department of Education. Okay, sorry. They expect you to know everything. Right. So now in 4.1.2, right. So there are a couple of things you need to know because now the brackets were shifted. We can see there was a shift in the brackets because the brackets were around -6 and 2. Now the 4 was brought in, so the brackets were shifted. The brackets were shifted because now the actually were around -6 and 2, so they were shifted to actually between 2 and 4, etc. And this property has a special name. It's called the associative property. It is called because association is, if you associate, you are making friends. You associate now with your friend in school, and you are forming one group with your friend. When you form one group with your friend, then next day in school, you realize that your other friend is maybe you are associating now with another friend for some other reason. You you associate with your friend B if you are A. If you are A, you associate with your friend B.
B.
And then after that, you realize that, hey, what's happening here? Okay, but now let me associate with, instead of associating with B, B now associates with C. B now associates with C. So they are friends. So they are together in one group, in one group within the parentheses, within the brackets. Okay, right. And this property is called the associative property for integers. Associative property. Associative property. Associative property. So now it means we have the associative property. Associative property of addition. This is called the associative property of addition. Right, so here you can effectively say it is the associative property of addition for integers. Associative property of addition for integers. Sorry, right, of addition for integers. For integers. What are integers? Have you ever heard of integers before? What do you think
Yes.
integers are?
Negative numbers.
Negative numbers. Okay, that's fine. Okay, good. So let's speak about integers a little bit. We call these integers. Right, integers are the numbers whose set is z. And the z has -3, -2, -1, 0, 1, 2. Here, you put 2 there, 3, and so on. So these numbers in the set z, the z is a special type of z. It's not just any z. It has some 2 slanted lines there. And this kind of z constitutes a very famous set in mathematics called the set of integers. Okay, right. So these numbers inside this set are called integers there. And then their numbers we call whole numbers. What are whole numbers? I'm just teasing you because I know that you have learned this in grade something, grade 1, grade 2. What are whole numbers?
Positive.
You remember them?
Yeah.
Okay,
I
because
do.
I'm testing you. You'll forgive me because sometimes I test people, Okay. What do you think whole numbers are? What are whole numbers?
Opposite of the negative, opposite of
Okay,
negative.
that's fine. That's fine. Whole numbers begin from 0, 1, 2, 3,
Um,
4, and so on. These numbers are called whole numbers. Okay, there are certain numbers we call natural numbers. What are natural numbers? What kind of numbers are called natural? What are numbers that are natural? What are natural numbers?
I'm
Natural numbers are 1, 2, 3, 4, 5, 6, and so on. These numbers are called what? Are called natural
natural
numbers. Okay,
numbers.
right. We continue. We continue. We are brainstorming here. This is called brainstorming. I'm going to send you this video. When I send you this video, you watch, you take down the questions, you write down the answers in a separate book, not in your school book. Your teacher is going to be surprised about by these things. They are part of the curriculum. These worksheets are part of the curriculum. The next question. Okay, we are done with worksheet 1. Worksheet 1 was just for us to build some basics and it was actually for ice breaking, for us to remember some of the basics. Let's get to something more serious a little bit. Okay, as part of the grade 7 syllabus, learners must be able to identify a variable. They must be able to identify a coefficient, and they must know what constants are. What is the variable in question 1.1? What do you think? Here's the question. You have been given 3x plus 2 equals 17. What is the variable in the question? What do you think? I'm just giving you a chance to show us what you're made of.
Mm,
Have you ever seen such a question before?
yes,
Maybe not.
but I struggle with
Okay, that's
this.
fine. I always test because you know why I test? Because I need to know what you have
Mm,
learned and what you have not learned. Because
yeah.
by the end of today, we shall be doing complex mathematics, advanced mathematics. That is what you're going to be doing. Right. So now here is the question. Worksheet 2. The variable is x. The variable is what? Is x.
X.
There's something we call the coefficient of x. What do you think the coefficient of x is in this problem? Okay, never mind.
3, I
Because I test you all
believe.
the time. Okay, because I don't want you to sleep, because sometimes if you're just on your screen like that, you can just be watching and then you find yourself sleeping. Okay, so I'm trying to make sure that you don't sleep and your mind is active. That's why I tease you by asking you some stupid questions, if you like, or some silly questions. Like, what is the coefficient of x? The coefficient of x is the number before x, and the number before x is the number what? Is the number 3, and therefore
Yeah,
the coefficient of x is the number 3. Okay, you must
3.
know this for exam. Right. What is or are the constants? There are numbers that are called constants. What are the constants here? Constants are those numbers that have no x next to them. Okay, like the number 2 is a constant. So the answer here is that the number 2 and the number 7. The number 2 and the number 7 are what are constants. They are
Constants.
constants. What are constants? Constants are numbers with no variables. Constants are numbers with no variables that multiply them. Multiply them. So constants are numbers with no variables that do what? That multiply them. Okay. So like 2 is not 2x, it's just a constant then. And the number 17 is also a constant because it's not like 17x or anything, or it's not like 17y, etc., etc. Next question. The formula for the parameters. So as part of the curriculum for grade 7, you must know the formula. You must know some formulas. How? You must know the formula for the perimeter of a square. Okay, the examiner decided to be very kind in this question. They decided to say, let's give to you. So they gave to you the perimeter formula. What is the perimeter formula? The examiner was very kind and very generous. And he said, the perimeter is 4s. The perimeter is what? It's 4s.
4s.
So in other words, the formula for the perimeter of a square, the perimeter
Square.
is 4s. If you have a square, what is a square? What do you think a square is?
Quadrilateral.
It's a quadrilateral with all sides equal. With all sides what? Equal. But with each interior angle equal to 90 degrees. So this is a square. Okay, all the sides are equal, and also the interior angles, each one of them is equal to 90 degrees. Because this one is a square. There is another, okay, all these are called quadrilateral. What is a quadrilateral?
Shape with 4 sides.
Yes, a shape with 4 sides. Now, a geometrical shape, a geometrical formation, a geometrical shape with 4 sides is called a quadrilateral. Okay, we continue. So if it is called a quadrilateral, so that's a square. And then the next one is this one, that one, that one. What do you call this one here? This shape here?
And it's a rectangle, but
The rectangle? Well done. It is called a rectangle. What do you call this shape here? Okay, I'm just drawing the shape like this. And then, what do you call this shape here?
rhombus.
Okay, you're close. A rhombus has all sides equal.
Oh, okay.
So rhombus would mean all these sides are equal. The opposite angles are as well equal to each other. So this one is called a parallelogram.
Oh.
Okay, because, well, we understand the sides are parallel to each other. The opposite sides are parallel to each other. So this one is parallel to this and this parallel to this. Right, so this one is called a rhombus. Okay, now if you look at the formula for the perimeter of a square, the perimeter of a square is 4s. What is it? 4s, right?
Okay.
So where s is the length of the side, so the side is s units, s units, s units, s units, and then we add everything up and then we get the answer. What is the variable in the formula? What is the variable in the formula? The
S
variable in this formula is what? What do you think?
is S.
Yes, it is the letter S. So the variable in the formula here is the letter S. So, right, it is the letter S. But also you can say this one here, because the perimeter is that, normally we write that P equals 4S, so that ideally the variable would be S here, but also you would remember that potentially also P for perimeter. P for perimeter. Right. Obviously, the examiner just gave a hint here. But the perimeter now, normally we write P equals 4S. Like the formula for the area, we normally write area is length by breadth. Okay, we don't write the word area. There's nothing wrong with writing the word area like in full, like that. What is the coefficient of S? What do you think, 1.2.2? What is the coefficient of S?
It is 4.
It is the number 4. Well done. It is the number 4. The number 4, this guy here, is the number 4. That is called the
4.
coefficient of what? Of S. Do you get the point?
Yes.
It's called the coefficient of S. Next question. Okay, as part of the grade 7 curriculum, you must be able to write a word problem which represents the following number sentences. A word problem which represents the following number what? Sentences.
Sentences.
Okay. Let's look at this one here. Let's convert the problem into a word problem. 2.1. What do you think the answer would be?
Uh,
Do you understand the question?
yeah, I do, but how do I like start it? Like, where do I start?
Where do we start? All right, that's
Yeah.
fine. We are practicing here. Okay, sorry, it's not a wrestling match. It's not WWE, SmackDown or anything like that, right? So in 2.1, we are really saying write a word problem which represents the following number sentences. We must convert this one into words. Into what? Into words. And that is called a
Words.
word problem. So now to start that, we say a number is multiplied by 2 right. So the word problem can be converted to this. A number is multiplied by 2.
2.
You can put a full stop here. The answer is equal to 100. 100 and what? And 20.
Yeah, it's 120.
A number is multiplied by 2. The answer is equal to 120.
20.
So a number x is multiplied. You don't have to say number x, but you say a number is multiplied by 2 because we take the number x, we multiply it by 2, and the answer is equal to 20. So we have converted this problem into a word problem. Okay, right? So 2.2. What do you think the 2.2 should be? How can you convert it to a word problem? So you describe it and now you do it like we did in 2.1. What do you think?
A number is multiplied by 3
Yes.
minus 1/2.
Yes. Okay. Yeah, you're on track. Well done. Congratulations. Right. A number is multiplied by what? Is multiplied by 3.
3.
Right. So you can even put the 3 in words because just to make sure you have words here. So a number is multiplied by 3 and then decreased. and then decreased by half the number, decreased by half the number, the answer
Uh,
is equal to, the
30.
answer is equal to 30, right?
Yeah.
Is equal to 30, right? Is equal to 30. Right, so this would be the situation that the number is multiplied by 3, okay? The number x is multiplied by 3. Because we're subtracting, we then say it is then decreased by half the number. So we decrease, meaning you subtract by half. That's half 1/2, the number. The answer is equal to 30.
30.
You get the point? Okay. We're in business and we move to the next question. Okay, sometimes they can give you some stories like this. We call these word problems. They can give you some word problems. And they can ask you to convert these to the answers. Like, what is this? Okay, the first question is about Andrew. Andrew thinks of a number. Andrew thinks of a what? Of a number.
Oh, yeah. Okay. They
Okay.
multiply them.
He
2.
multiplies the number by 2 and gets the answer 30. Write Andrew's problem as a number sentence. As a number what? Sentence.
Sentence.
What do we do here?
Right.
Andrew thinks of a number. He multiplies the number by 2 and gets the answer 30. Write Andrew's problem as a number sentence. Andrew thinks of a number. He multiplies the number by what? By
2.
2. Okay, so Andrew thinks of a number. He multiplies the number by 2, and then he gets the answer 30. Write Andrew's problem as a number sentence. This is exactly what Andrew is dealing with. So we're saying Andrew thinks of a number. He multiplies the number by 2. So the number is x. He multiplies it by 2 and gets the answer 30. Write Andrew's problem as a number sentence. So it is exactly that one there. Okay,
Yes.
let me give you like 3 minutes so that you try the question. Please read question 2 aloud a little bit so that I can hear you.
Okay. Jessica thinks of a number. She adds 3 to the number and gets the answer 25. Write a
Okay.
number sentence to represent this problem.
This, the last sentence, what is it saying?
Chad thinks of a number. He divides the number by 3 and adds 4. His answer is 29. Write his problem as a number sentence.
Okay, good. Let me give you 3 minutes. You try,
Okay.
you think about it, and then when you thought about it, you let me know, and then I will ask you so that I can see what you think about it. You let me know and say when you say I'm done.
Okay, I will. 20.
Okay, let me know when you're done.
Almost done.
Okay, that's fine.
um,
So these paper have different questions. So this one, but right. So you get square both sides of the equation. Okay, you're done.
no, I'm still on
Okay, that's
3.3.
fine. I'm giving you 1 more minute.
Okay.
Okay, yeah. Never mind. I know that it's easy. Right. Jessica thinks of a number. She adds 3 to the number and gets an answer of 25. Write a number sentence to represent this problem. So Jessica thinks of a number. Let's say the number is X. She adds 3 to the number. So you add 3 and she gets an answer of what? Of 25 like this. Write the number sentence to represent this problem. That is the number sentence, and we are done. Okay. So, yes, let me give you one more. Chad. Chad thinks of a number. He divides the number by 3 and then adds 4. His answer is 29. Write this problem as a number sentence. You see what Chad is doing? Chad thinks of a number. He divides the number by 3. And then after that, he adds 4. His answer is 29. Write this problem as a number sentence.
So,
So what do you think
so
of this one?
is it X divided
Okay.
by 3?
It is x
X,
divided by 3 because Chad divides the number by 3. So it is x divided by 3 and then they add what? What does Chad add? Chad
that's
adds
4.
4 and the answer is what? Is 29. Write this problem as a number sentence. Write this problem as a number sentence and we just have got it. We've got it. And we say, because we've got it, we say Eureka. We say what? Eureka. What does Eureka mean? And when do we say Eureka in mathematics? We say Eureka
Um,
when you got the answer to a problem and we're celebrating.
oh, okay.
Then we use the word Eureka to celebrate, because that is what the mathematicians who lived in the past always were saying. Okay, they said that at some point when they were when they'd got something right. So now we continue, obviously, but I'm going to speak a little bit in brief about the use of the word eureka in mathematics, okay? Because we are learning more. Right, so eureka is actually a cry of excessive joy or satisfaction, a cry of joy or satisfaction when one finds or discovers something. A cry of joy or satisfaction when one finds or discovers what? Something.
Something.
Okay, that is it. So you say eureka. It is a cry of joy, satisfaction. You see, if somebody is actually expressing a cry of joy, it's not that they are crying because they are sad. You know, they are not happy. They are full of what? They are full of joy. They are full of satisfaction that they got the answer to the problem that was bogging them, that was challenging them. Now they have the answer, and then now they've discovered something. So a cry of joy or satisfaction when one finds or discovers something. When a person finds or discovers something, we say eureka. Next question. If x plus 5 is 12, what is the value of x? Let's do this one as an example. What is the value of x? Right, so we do this one in 4.1. So in 4.1 now we have the question x plus 5 equals what? 12.
So it's
You transpose the 5. What does it become? Negative. You transpose the 5. What does it become?
negative.
What is x? What is 12 minus 5?
7.
7. So that is the value of x.
X.
Alternatively, you can do this. You can say you have x plus 5 equals 12. Then you have x plus 5. You subtract 5 from the left. And then whatever you have done on the left must be done on the right. So also subtract 5 on the right. So that 5 minus 5 is what? Is actually 0. And then what is 12 minus 5? It is 7.
7.
It is exactly what? 7. And that's the answer. Right, what is the value of y in the following equations? I'm giving, because it's 3 marks, I'm giving you like 3 minutes to do 4.2.1. And when you're done, let me know, please, and say, okay, I'm done. And then we can check your answer there. When you're done, then you're going to give me the answer. You're going to tell me if the answer is 1 billion or 1 trillion or whatever. Okay, yeah, the clock starts now. Please start trying. Think about the answer.
Hmm.
Okay, what do you think? Are you done yet? Are you done yet?
No.
Okay, that's fine. Let me give you 1 more minute.
I don't really understand.
Okay, that's fine. That's okay. Right, so we're looking at 4.2 and then we're looking at 4.2.1. Right, so we're given the question, which is 3y plus 5. 3y plus 5 is equal to 20 what? 23,
We
right?
need
So first things first, we need to remove the 5 because we want to get the value of y. So to remove the 5, what do we do? Because the 5 is adding. So we have 23. So we subtract 5 because it's having a plus, so minus. And then we also subtract on the right-hand side. So now we have 5 minus 5 is equal to what? 0. We don't write the
0.
0. And then what is 23 minus 5? You get exactly 18, right? And then when you get to this point, we have 3y is equal to 18. So you want to remove the 3 now. You must divide by 3 on the left, divide by 3 on the what? On the right. And then we get y. What is 18 divided by 3? It's 6.
6. Yeah, 6.
So the answer is 6. Yes, I get got a 6, right? All right.
Yes.
All right. Okay, good. Let me give you 3 more minutes. Try 4.2.2 and let me know when you're done, please. Looking at question 3, and this question is part of what was task, and it's extremely important for us to put the fact that um, um, not big, or there are many points C like that. Of course, we can have the point C that is here, the coordinates x, c, y, c. So as a consequence, in the end, the point C are ready. And if you combine all points C, they make the calculation of the total with the multiplied points. Let me know when you're done, please. I hope you're not sleeping. So,
No, I got this one wrong.
okay, never mind. Because I'm just testing you. Because I know that for you to be fit, you must be tested, you know. So in 4.2.2, you have 4y minus 10 equals 90. You have 4y minus 10. You add 10 on the left. You add 10 on the right, which means for y, what is 90 plus 10?
100.
100. Okay. So after we got, because we want to remove the minus 10, because it's a negative, we add a positive. This 5 was positive, we minused, we subtracted, right? Okay. But
Mhm.
here now, because it was the 10 was negative, we added. So we get this. And then out of this now, you want to remove the 4. How do you remove the 4? Because it's multiplying, you divide. So you divide whatever you do on the left, you do on the right of the equation. So you divide by 4, and then you get that y equals what? Y equals this one, which is 25, okay? So that becomes the result. That becomes the result over there. And that is the answer. And so now let me give you some a home activity on these two. Right. So you must have a home activity. What is the home activity? Right. The home activity will be um, find the value of x. Find the value of x. So you'd have 5x minus 2 equals 12 or equals 13. Right, so this is 13. So we have this. 7y minus 3 is equal to 18. So take these problems here. And now these ones here in the green block, they are a home activity for you. So you're gonna try them, and then you can let me know what when you have them. In during our next meeting, we're gonna discuss this. Okay. And so
Okay.
we will need to have 4 meetings every week, every for this month of October. 4 meetings, 4 meetings. So this is one meeting. So a meeting can be next weekend, either Saturday or Sunday. You let me know, and then we start. Okay, we continue the next one.
Okay.
Question 5. Find the value of y in the following equations. Let's do this one. If y is equal to 4x, when x is 11. So it means that here we proceed as follows. So it means we have that y is 4 times x. What is x? X is 11.
Mm, yeah.
Right. So it's 4 y is 4 times x. Let me write a little bit in some detail. Let me write a little bit in some detail. So you have y is equal to 4x. And x is what? Is 11. What is 4 times 11? It is 44.
44.
Right. So this is the answer to the question, because they said find the value of y in the following equations. And so we did that. So if y is 4x, find the value when x is 11, and you got 44. Right, let me give you the next one. Try 5.2. I'm giving you 3 minutes. 5.2, I'm giving you 3 minutes.
Okay. Yeah.
And then you let me know when you're done. Okay, so you're gonna let me know when you're done.
Yeah, I'm finishing.
Okay, that's fine.
It's okay. Okay, I'm done.
You're done. Okay, what do you think the answer is?
36.
Okay, good. So yeah, that's the correct answer. Congratulations, because y is equal to 2x plus 16. So we write y equals twice x plus 16. X is 10.
Okay.
X is 10 plus 16. What is 2 times 10?
20.
20 plus 16. What is 20 plus 16?
36.
It is 36. So that is the answer. Okay, let's look at the next one. Let's look at the what? At the next question. Right, so if you look at this one here, you have y equals, okay. Let me give you 3 minutes to try that one, then we do it together. It's a worksheet, so I'm expecting to work with you. That's the reason why we're calling these worksheets, because we need to work together.
Okay, I'm done.
Okay, what do you think the
Is
answer
the
is?
yeah, is the answer 10?
Okay, let's do it together. Right, so y is what? Y is 3. X squared minus 20. What is x? X is 5 minus 20. What is 5 squared? It's 5 times 5.
25.
Okay, so
25.
5 squared means 5 times what? 5.
5.
Okay, what is 5 times 5?
25.
It's 25 minus 20. What is 3 times 25?
75.
75 minus 20. What is 75 minus 20?
It's uh,
55. It is what?
55. Yeah.
55. And that is the answer. That is exactly the what? The answer. Okay.
Okay.
Note that. Next. Right. The next thing we need to discuss is worksheet 3. Okay. But worksheet 3 I've prepared and we're going to discuss it. But also I want us to look at the final exam. The final exam. Because you're going to be writing the final exam very soon as the grade 11 learner, you know. And so
Yeah.
now, as a grade 11 learner, when you're going to be writing your final exam, you need to know what to prepare for the exam. Let's see. There's a multiple choice that normally will come in the exam. Like this. The highest common factors. Let's look at the exam. Right, here is the multiple choice. Here are multiple choice questions. We call these questions, what do we call them? We call them multiple choice.
Good.
Right, write down the letter of the correct answer next to the question number. What is 2 in 2x plus 3 equals 7? In the exam, they'll ask you something like this. What is 2 in 2x plus 3 equals 7? What do you think? Let me just give you 1 minute because it's just 1 mark. What do you think the answer is?
A constant.
Okay, here is the number 2. The number 2 is actually close to x. A number close to x is called the coefficient. I know you're still learning these things. It is called a coefficient. So the correct answer is B. Okay, 1.2, an algebraic number sentence which consists of constants and variables with no equal to sign. An algebraic number sentence which consists of constants and variables with no equal to sign. Okay.
And
Your thoughts?
Formula.
Okay, that sounds very, very interesting. That sounds very, very interesting. Right. But now, okay, we did a formula for, what is the formula for the perimeter of a square, for example? What do you think? Sometimes I get you to think, you'll forgive me, please, because I want to make sure that we talk, and I'm sure if you're following or not. Okay.
Perimeter. Four sides.
Yes. The perimeter, we saw that formula, it was like 4s, right? It was like 4s, 4 sides, right? So well done there. Right. So an algebraic number sentence which consists of constants and variables with no equal sign is called an expression. It's called what? An expression. And examples of these would be an algebraic number sentence with constants and variables. So I can give you 3x minus 8. This one here, it has no equal sign. Okay, so it is called what? It is called an expression. It's called what? An expression. It's called an expression. A formulae would be the area is equal to length by breadth. That's a formula. But the formula, most of these formulas are equations themselves. Because an equation, what does equation mean? Equation means there's an equal sign, like x equal to 2 is an equation, you know? Because equation means two things are being equated to each other. Right, so algebra. They put some word algebra. Algebra is the part of mathematics that deals with these numbers and the formulae and so on, right? So you have that. Next question, please. If x minus 5 minus 9 is equal to minus 9, then the value of x is 1 minute I'm giving to you, and then we shall do it together.
It is -4.
What do you think?
-4.
Okay, let's go 3 together. So we have x minus 5 is equal to minus 9. And so we have this, so we're gonna add 5 to the left-hand side of the equation, but we also need to do the same thing on the right-hand side of the equation, and therefore the answer is -4, and therefore the correct answer is B. Okay, correct answer is B. The correct answer is exactly that one. It is B. Next question. What are the next two terms in the sequence, that one? What do you think?
23 and 26.
23 and 26, okay. Can see they increase by 3, right? Because this one increased by 3 to this, by 3 to this, by 3 to that. So you get 23 and 26. And so the correct answer is B. Correct answer is B. You agree?
Mhm.
Okay. 1.5, I'm giving you 1 minute. What do you think?
Mm,
You cross multiply here. What do? You cross multiply. So if you cross multiply, this 4 is like out of 1. So it becomes 32 times 1 is equal to x times 4. Okay. What is 32 times 1? It is 32 is equal to 4x. You want to get the value of x, so you divide by 4, which means x is 8.
128.
Please come again.
Is it 128?
What do you think 32 divided by 4 is?
128.
Um, please divide again. 32 by 4.
Divide 32 by 4.
Yes.
Oh, I thought multiply.
Oh, yeah, that's what I realized. Because it was reaching like hundreds, I realized that you're multiplying.
Yeah, it's 8.
It's the number 8.
Yeah.
So if you look at 1.5, the answer is 8. So it is D there. Next one, 1.6. Let
Oh,
me give you 1 more minute to try 1.6. And when you're done, please let me know.
okay.
Okay. Mhm. What do you think the answer is?
6.
I think the answer is 6. Okay. Use a calculator. Never mind. Right. So at this point, then you have this is called the radical sign. It's called the radical sign, or it's also called the square root. Square root what? Sign. It's called the square root sign. So at this point, if you have the following, oops. Okay. So now if you have this, where are we now? Into something else. Right. So you have the number 2 there. You have a 65 plus 36. What is 65 plus 36? Right. So you first add the tens, 60 plus 30, you get 90. Then you add the units, 5 plus 6, you get 11. Then you have 90 plus 11, which is what?
Um, 101.
101, right?
Yeah.
You're getting 101. Is that correct? Okay.
Yes.
Right. If we're getting 101, then what is the next thing? And how do we calculate these here? Right. So you're getting 65 plus 36. 101. And then what is the square root of 101? What is the square root of 101?
Mm,
Okay, so 101 is approximately, you need to use a calculator for this one, is approximately 10,0498, 7, 5, 6. So it's approximately 10. It's approximately what? 10.
10.
You round it off to the nearest tens. So it's approximately 10, and then
Approximately, I run it off. I round it off by
supposed to have a lesson.
two.
Supposed to have a lesson by 2, but now she's not around. She's somewhere by
Yeah,
church, so she's
five.
coming. Can you please move it to 4 o'clock?
To the nearest,
okay, what do you think?
I round off the 10 to the nearest 5, or
Please come again.
do I round off the 10?
We will round off to 10, right?
Yeah, so speed.
Yeah, so it is approximately 10, and therefore the answer is what here? 1.6. The answer is B. The answer is what? Is C, excuse me. It is what?
C, 10.
Yes, approximately 10. Okay. Approximately 10. Next question. Okay, the prime factorization of 120 is what? Is the answer A, is the answer B, is the answer C, or is the answer D? What do you think? Let me give you 1 minute to think about this. I know that you have learned some of these things, so I just want us to discuss them as you prepare for the exam.
C.
You think the correct answer is C, right?
Yes.
Yes, C is the correct answer because if we are to do the prime factorization, we remember that one, we draw this step ladder and then we put the number 120 here as at the top of the step ladder. And then we divide by the number, the number 120 by 2, we get 60. And then we divide the number 60 by 2, we get what? 30,
30.
right? We divide the number 30 by 2, what do we get? We get 15, right? We need to divide the number by the smallest of them, a number that divides 15, and the smallest number divides 15 is 3, giving us the number 5. Right, and then you divide the number 5 by what? By 5, and you get the result of 1. Right, and so the prime factorization is going to be the product here. And so it means, therefore, the prime factorization, is 2 times 2 times 2 times 3 times 5. Okay, so how many twos are there? There are 3 of them. So there are 1, 2, 3, and then 3 and a 5, and the correct answer is C. Right, B, 1.8, excuse me. Right, a prime number is what? Okay, 1.8, so we have that a prime number is a number with 3 or more factors, a number divisible by 3, a number with 2 factors, an odd number. Which one do you think is correct here? I'm giving you 1 minute.
Number with 3 or more factors.
Okay, right. So that's an interesting one. Mm-hmm. Mm-hmm. Anyway, I'm just looking at the options. I'm just looking at the options here. Okay, let me just remove this canvas. So if you look at 1.8, um, so the correct answer would have to be what? A number with 2 factors amongst this. Right, because a number with 3 factors, like, it's not really prime because prime numbers are the number 2 is prime, the number 3 is prime, the number 5 is prime, the number 7. So they have the factors 1 and 2 only, or 1 and 3 only. Okay, so they have those 2 factors. So these prime numbers are only divisible by 1 in themselves. You get the point. So that is what we have. All right. So a number with 2 factors would qualify because an odd number like 9 is odd. 9 is odd, but it's not prime. Why? Not prime because it is
Because
also, it is divisible by, it's not that 9, the number 9 has the factor 1 and itself. You get the point. So you have that. So let's look at some of these questions. So there are a lot of them that I'm gonna okay, let me just give you something to conclude our discussion. I know that you need to take a break and relax also. Let's look at this one. Convert this one to an improper fraction. Convert this one to an improper fraction. I'm giving you like 1 minute. And let me know what the answer is. Let me know when you're done, please.
Uh, uh,
Okay. Any thoughts?
not. Yeah, I'm having trouble. Yeah.
Okay, with this one, let's look at what is an improper fraction? What kind of a fraction is improper?
When
Improper, like I can give an example, like 5 divided by 2 is improper. So improper is different from proper, is the opposite of proper fraction. These are fractions that are called proper fraction. What is a proper fraction? This
when the
one is called
denominator,
improper.
yeah.
What is a proper fraction? Right, this one I can give like 2 over 3. So here it means that the numerator is less. Numerator
The denominator.
is smaller than denominator. Here, the numerator in the improper case is bigger. Is bigger than the what? Denominator.
Denominator.
Okay, so because the numerator is bigger than the denominator, numerator is bigger than the what? Denominator. So since the numerator is bigger than the denominator, it's called improper. So that is what this is. Just to convert this one. So if you have 11 in 2 over 3, what is 11 by 3? 11 times 3. Right, so you must
36.
say 11, you must say 11 times 3 and then you add 2.
36.
Okay, that's fine. I'm sure you're close to it. Okay, so you must say 11 by 3. 11 by 3 plus 2. You divide by 3. 11 by 3 plus 2. What is 11 by 3? It's 33 plus 2. What is 33 plus 2? It's 35 out
36.
of 3.
Oh, 5. That's 3.
Yeah, because 11 by 3 is what? It's 33. 33 by 2 is plus 2 is 35. So the answer is 35 out of that one.
R3. Okay.
You get the point?
Yes.
Okay, let's do something we call the highest common factor. Right, so as part of the grade 7 syllabus, you must be able to determine the highest common factor. The highest common factor of 24 and 36, what do you think the answer is to that?
It is. I'm
giving you like 1 minute. I know it's easy. All right, I know you're thinking. Right, so the solution is as follows. Right, in 2.1, you must first get the factors of 24. The factors of 24 and the factors of 36. What are the factors of 24? 1, 2, 3,
2,
4,
3, 4,
6,
6,
8, 12,
8,
24. What are the factors of 36? 1, 2,
2,
3, 4,
3, 4,
6,
6,
9,
9,
12,
12,
18,
and
36. So we have that. So now we're looking for the highest common factor. What is the highest common factor? So which means, therefore, the highest common factor will actually become 24 and what? The highest common factor of 24 and 36. Highest common
is
factor
12.
of 24 and 36. What do you think it is? 12. Right. As your homework, you're going to do 2.2. As your homework, determine the lowest common multiple of 24 and 36. So this one is your home activity. Okay, is your home activity. Right, that is your home activity to do at home. 2.2. And then also there is this one is your home activity. Your home activity. What is the home activity? The lowest common multiple is. Well, you think about this one, okay? 1.9. That is your home activity. I'm going to discuss this in my next lesson, okay? So 1.9 is your home activity. I'm going to send you the video. So you're going to see it again, okay? And then 2.2 is the home activity that you're going to do. And also, your BODMAS and your BEDMAS. Okay, there are two rules. Some teachers call it the BODMAS rule, but some teachers call it the BEDMAS rule. So it depends on the teacher. So now you need to try these problems, 3.2.1 and these. So also these two guys, they constitute your home activity. Okay. And this concludes our discussion for today. We started a few minutes after. We started a few minutes after 12. So when we started a few minutes after 12, we went through the questions and we solved and solved and solved and solved and solved. Right, okay, but maybe I can give you something to try during our discussion right now. Right, how would you write 3.1.1? Write in exponential form, what do you think?
2 to the power of 3.
What do you think?
I think it is 2 to the power of 3.
Okay, how many 2's are there? 1, 2. So it means that it is 2 to the power of 2, right? Times how many 3's are there? 1, 2, 3. So it's 3 to the power 3. Okay. Write in expanded form. This one, what do you think the answer is to 3.1.2?
2 times 2 times 2 times then
3 times,
5
right?
times 5. Yeah.
Yes. And then 5 4 times is 5 to the power 4 is 5.
That's 5.
5 by 5 by 5. How many times? 4 times. Okay. Start the power this and write down the base. What is the base in 3.1.4?
7.
The base is 7, right? Okay, I'm glad that you are aware of that. The base is 7. If you look at Calculate and show your calculations where appropriate. Um, if you look at what do you think the answer is to 4.2.2? Or let's start with 4.2.1. What is the answer to 4.2.1?
Uh, let's see. So it is, if we say 54 plus 24,
Yes.
then we, oh, I see. Okay. We add
Let me know when you're done. Okay.
okay, okay, so is it 78,163?
Okay. 4.2.1. Let's just do it together. So it's actually you have 54,92. You add that to 24,71. Right? You're performing the addition like this. What is 1 plus 2?
3.
3, right? Then what is 7 plus 9? It's 16, right?
16.
So you bring down 6, then you carry 1, right? So what is 4 plus 4?
8.
8 plus 1, 9.
9.
You bring down your decimal comma. What is 5 plus 2?
7.
7. So the answer to this is therefore the same as 79, 63. 79, 63.
3.
Okay, so we get these here. Okay, do 4.2.2, please. I'm giving you like 2 minutes. 4.2.2. I'm giving you like 2 minutes.
Is it 43,02?
It is actually 44.
Oh,
Something like that. Okay, so obviously in view of the question 4.2.2, there are a couple of ways to multiply those. Right, so if you have 6,2, and then we have 7,1. Multiply like this. Right, so we multiply and say, what is 1 by 2? Right,
2.
1 by 2 is exactly 2, 1 by 6 is exactly 6. So you write like this. Right, so the next thing here is, after you've written like that, you actually just temporarily just leave your decimal comma here. You can leave them out. Then we have 7 by 2. What is 7 by 2? Right,
14.
in the case of 7 by 2, you can see that 7 by 2 is 14. Right, so you actually bring down 4, then you carry 1. 7 by 6 is 42, plus 1 is 43. So what you do is you balance with a 0 there, giving you a 2 here. And furthermore, what does it give you? If you add the 2, the 6, and the 4, you get a 10. So you bring down a 0. And then you carry a 1, which you add to the 43, and that gives you a 44. Right, so you realize a couple of things, that this one was to 1 decimal place. And this one here was also 1 decimal place. And then in the end, this one is 2 decimal places. Right, so now 2 decimal places will therefore mean that you are here. And therefore the answer here will be 44,02. Right, the difference between the South African education system together with versus the British education system. So we are talking about the South African. Right, the South African education system versus the British education system. South African education system versus the British education system. Right. So in view of the South African education system versus the British education system. So in the South African education system, we speak of 2,3, for example. But in the British education system, we speak of 2.3. So this is a decimal point. In Britain, we speak of a decimal point. And also in Britain and also in America. In the American education system. So in other words, if you speak to the American children who are in 7th grade, you realize that they are taught to write 2.3, but in the South African education system, those learners that are in 7th grade, they are taught to write 2.3, and therefore in South Africa, we use what we call the decimal comma. Right, the decimal comma, therefore, is read as 2.3, then rather 2.3. This notation is seen in other countries in the world, like in Brazil. In Brazil, they write also like in South Africa to mean the decimal fraction. So the Brazilian number system is and the pattern of writing has some similarity to the South African system of writing. Okay, so those are the kinds of things that obviously you need to just be cognizant of as a homework, as your home activity. Home activity 4.2.3. 74,23 divided by 10 is just one mark. That one is too easy. But yeah, you let me know what you think in our next meeting. And also, you must be able to calculate and leave your answers in its simplest form as mixed numbers where appropriate. Here we have mixed numbers, right? So in the event we have mixed numbers, so you deal with all these and actually continue with this. And we are done with this. Okay, this learning was so interesting. I feel like not stopping. I feel like going on and on and on. Okay, I prepared a lot of things. I prepared a lot of things. Okay, I said 3.2 is your homework. Home activity 1.9 as well is your home activity. All right. All right. I think I must thank you for joining us. And then we will talk again. Are you free on Sundays? What time are you free on Sundays? So that maybe we'll fix. On Saturdays, are you free? Are you available on Saturdays?
Yeah, I am.
What time normally on Saturdays can you do our lesson? Like today, we started at 12. And I
Yeah, we
realized
can
that
do.
you are running from church. You know, maybe 12 was not the best time. Maybe we should have started at 1.
Yeah, one is, yeah, it's been
It's better.
available. Yeah.
So 1 is better so that you go to church, you don't run from church because, or maybe 1 o'clock. If 1 o'clock is not enough, we can even start at 2 o'clock on Sunday.
Yeah, 1 o'clock is enough. It's fine.
1 o'clock is enough. Are you sure that you're not going to be running from church?
No.
Okay, so that's
Not
fine. So you can consider that. Then, all right. Saturdays, how are your Saturdays? What
Yeah,
time are
I'm
you
free.
free? What time are you normally not busy, not at school, not playing
Uh,
soccer, not doing
I'd
volleyball?
say, yeah. I'd say one, around about that time, yeah.
About 1, eh?
Yeah.
All right, because I'm thinking about how we can schedule our lessons. Let's say Saturday at 1.
Yeah.
Saturday 1 p.m. Okay. For Saturday 1 p.m. we're gonna meet and continue. Okay.
Okay.
Then Sunday we're gonna add more, but we need just 4 lessons every full month. So we need like Saturdays at 1. We're gonna do 2 hours, and then we shall see what we do. We'll just add the Sundays so that the Sundays are extra. Okay. All right. Thanks a lot for joining us. I will see you again next Saturday. Please remind me your name because I know that I know my wrong.
No, I'm Lensway.
Please come again.
Lensway.
Oh, Lensway.
Yeah.
All right. We are speaking to Sunshine anyway, the tutor. Okay, the math and science tutor. Okay.
Okay.
Right. Thanks a lot, then Lensway. I will see you again on Saturday, this coming Saturday at 1 p.m. Okay.
All right.
Okay. Thanks a lot and have a very good evening. If need be, we shall meet more. I can meet you during the week, but I don't like during the week because I know that,
I'm busy
yeah,
during the week.
yeah, you're
Yeah.
busy during the week. Yeah. Okay. So thanks a lot then. I'll see you Saturday,
Yeah.
1 p.m. Okay. Thanks. You must tell your mom about this. Okay.
Okay.
Okay. Thanks, Lindsay. Goodbye. I will send you the
Right.
video
Bye.
soon. I'll send you the video soon. Goodbye.
Okay.
All
Bye.
right. Mhm.